Hey guys, what's up? So in this video, we are going to create a tiny DLL for Windows using C. So let's get started. Now, I have a C file called tiny.c, which defines a function say hello, and it is calling a Win32 API message box A, which will be showing this message on a message box when being invoked. And we are also exporting this function using DLL export so that other programs or processes can use this function by using our DLL. Now let's try to compile this and create a DLL out of it. For creating a DLL, we will be using the CCPP compiler from Microsoft, that is CL. And in order to create a dynamic library, by default, it creates an executable. So we'll use /ld. Then I'll say tiny.c, which is the source file. And now, in order to use message box A, this method is part of Win32 API, and it's provided by user32.dll. So we need to link with user32.lib, which will be helping us to resolve those symbols, and you can press enter. Now, if I do dir, it is creating a DLL called tiny.dll. But this time you can see that it's not that really tiny. It's around 83 KB in size. Now let's analyze this file. So I'm going to open a tool called Cutter. And here I have already opened that DLL before. And you could see its size is around 82 kilobytes. What you could do is you could just open the location where the DLL is present. You can just drag and drop it. Same way you could do with any kind of exe or DLL files. I'm just going to open it. Now it's open, and you could see that there is an entry point to the DLL that is called DLL main CRT starter. The DLL main gets invoked when you actually load the DLL and get it attached to a process or a thread or detached from a process or a thread. For any such initialization, the DLL entry point is being invoked. And the DLL entry point always should have this signature where it is taking a 4 bytes argument, total of 12 bytes. And here it is doing some CRT setup. CRT means C runtime. So CRT setup is actually done to initialize things in such a way that we would be creating an environment where we could call the standard C library functions like scanf, printf, etc., without which we will not be able to call it in a Windows program. So CRT setup is usually done by default by the compiler when we create an executable or a DLL. Okay. And there are so many other things that is defined here. And as we scroll down, we could see that this is the function that we actually defined, where it is setting up the arguments, and then it is calling the message box A method. Now, if you go to imports, you could see quite a lot of imports happening here from kernel32.dll. But if we scroll all the way down, you could see user32.dll for message box A method. And this is the only method that we are actually using, and remaining all method comes into picture automatically because of the CRT setup. And this increases the size of the DLL quite a lot. Now that our function is not dependent on, if you go to our function again, you could see that we are not dependent on any kind of standard C function. We are only directly using Win32 API, which is not dependent on any kind of standard C libraries. So it is safe for us to remove the CRT part of our DLL, and then we can reduce the size of the DLL. One thing to realize is the moment we remove that part, we will not be able to use standard C library functions inside our DLL. Now let's see how to do that. We'll just close this. Now I'll make a copy of the tiny DLL so that we could later compare copy tiny.dll. We'll call it big.dll. Now we could just clear the screen. We will be using the same set of commands to compile CL and then followed by LD for the dynamic library. And this is the source file. We'll also say user32.lib because we need message box A method. And then we will say link. Then we will specify one more flag called no default lib, which will prevent any kind of CRT setup. But now when we press enter, we are going to face another challenge. You could see that DLL main CRT startup method or the symbol is not resolved. So how to fix that? This thing we can fix by defining our own entry point and then specifying our entry point using a new flag called entry, and then specify the function name here. So this function can't be just any function. Let's say, let's give our function itself as the entry point. At that time, it's going to throw another error saying that it is expecting a 12-byte arguments. If you remember previously when I opened this method in Cutter, Cutter was showing that entry startup and the function had the same name and it had three 4 bytes arguments, which makes it 12 bytes. Okay, so it is expecting a method of a particular signature to be the entry function. Or you could totally skip the entry function just by using a flag called no entry. But for our case, we will be defining an entry point. So let's call it DLL main. I'll go to the source code. So this is the DLL main and it should follow the same signature. You could literally use any function name. I just kept it as DLL main because it makes more sense. And inside which we will not be doing anything. We'll be just returning true because that's just what we want. When the DLL is loaded and attached to a process or a thread or detached from a process or a thread, this DLL main gets invoked. So if you want to do any kind of initialization, we can do it here. For our case, we don't have to do anything. So we'll just keep it as such. Now we'll go to the developer console. Now, if I do dir, you could see that we now have a tiny DLL, which is just 3 KB in size. And just open the DLL in the cutter. Now we could see that the same tiny DLL is just 3 KB in size. And also you could see that there is nothing else here. It's just your function and an entry point. That's it. So that is the reason why the entire size got reduced. Okay. And we will make a small change to the method so that we can differentiate. Okay. So I'm just gonna close this and I'm gonna go to the source code. I'm just gonna say the message as really tiny and I'm gonna build it again. And one more thing I would like to show is within Cutter, you could go to imports and you could see that now we only have user32.dll as the import for this function. Nothing else is being imported because we removed all the default CRT things. So no other functions are being imported. Now you could run the function that is present inside a DLL using something called run DLL32.exe, which is provided by Windows. C drive, Windows System 32, run DLL32.exe. Then you can specify the DLL name. In our case, it is first one is big.dll and the function name is say hello. And you could see that we got a message box with the message hello from Tiny. And now we will replace this DLL with tiny.dll, say hello. And this also works fine because as long as it's just using the Win32 API and it's not gonna depend on any kind of standard C libraries, we are good. So you could see the new message, hello from really tiny. Now I would like to just introduce you to a tool called dumpbin. So you could just use dumpbin/imports, and then you could say big.dll. And you could see the same, whatever we saw with the tool cutter, you could see there is an import of user32.dll and it's for this message box a method. And there is an import of kernel32.dll for these methods. And these are actually done automatically by default for the CRT setup. Now you could run the same command on tiny DLL and you could see that it's only using user32.dll for this corresponding method. Hope you guys enjoyed this video. Thanks for watching. Don't forget to like and subscribe. Thank you.